Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the DB2Night show, and I got the number wrong. This is actually show number Z114. It wouldn't be my show if I didn't have a typo. That's the agony and ecstasy of doing this, but I did get the title right, and I did get our speaker right. We've got Sheryl Larson with us again today. How are you doing, Sheryl?
Oh, fabulous.
That's great. Me too. And if anything, I hope you've noticed that our sound is a little better, or my sound is a little better, because I went out and spent that DB2Night show budget I have and bought myself a new USB microphone from a local music store. And for those people that know, I attempt to, I've been playing trombone now for over 50 years, and I figured, what else are you going to do during COVID than record yourself? So I went and got a proper studio mic to do that on. So with that,
crystal clear. Sounds great.
That's awesome. That's good to know. Thank you. And just to get through the formalities and turn things over to Sheryl, because she is the person you tuned in to hear. It wasn't just me. So with that, here's our social media page as always. Twitter gets follow that hashtag DB2Night, and you'll be able to see the upcoming announcements of shows. This is reminders. I try to do those 2 to 3 days ahead of time. Our replays are on YouTube, so you don't have to download anything if you choose not to. And we also have our LinkedIn group, which is pretty light on traffic because pretty much these days we use the same format and people seem to like it. So, and also people know that if you email us, we are very responsive to emails. So with that, let's move along. Here's our disclaimer. Copyright 2021. There are trademarks and they're all respected. We love trademarks. We will record and make the replays available as people know. And we'll upcoming shows. As it stands right now on DB2LUW, we've got IBM is presenting some things on click to containerize and DB2 on cloud. This is something where I told IBM they could have a couple of time slots, and I said I suggested March and I suggested May, and I said tell people anything you feel as IBM that you'd like your customer base to know. And Tanmay and Vinayak are going to speak as well. The demo will be done, I've learned this week, by George Backlars. So we should have an action-packed show, and they're going to show you just how easy it is to use DB2 on cloud. April the 9th, I'm talking to a lab person. We'll have somebody from the IBM Toronto lab that day. And on May 7th, we'll likely have another presentation from the IBM marketing team, again, trying to increase the profile of DB2LUW. It's a great product, and I'd just like to see everybody in the world use it if they're not using DB2 on Z. Looking forward on the Z shows. Next month, we have Dave Belkey back with us. He's going to be talking about Java performance best practices. I'm expecting in, I've got confirmation for Steen Rasmussen for May 21st, and I'm going to put another consultant or an IBM lab person in on April the 23rd, and I will get around to setting up the June shows as well. iDoug has 2 weeks in June they're using, so I'm going to try to schedule away from their weeks just to. We don't compete with iDoug. In fact, they're one of our sponsors, so we'll work around with iDoug to make sure we still have content and that we do things in a cooperative manner. As always, we have the available from our founding sponsor. We have the demo available of their products available on the DBI site. If you want to watch a demo and get an Amazon gift certificate, that's a good thing to do. And as I'm going through this, I'm realizing my next screen, I forgot to update the winner's name. I knew I'd forget something else. I can look that up and I'll announce that next week. But we did send a gift certificate to someone, and when we selected the winner 2 weeks ago, the name should be on there, and it will be next week, I promise. such is my life. I can always forget to do something. And thanks to our sponsors, of course, DBI, our founding sponsor, and the hosting platform we use for the DB2Night show, and yours truly, Martin Hubel Consulting. And this week I figured there's nothing like a puppy to make people smile. Well, Charlie's hardly a puppy anymore because the pictures on the left are mainly what he's so good at doing these days, which is sleeping. Although right now he's in bugging my tail because he wants another liver treat. I've got a can of liver treats in my office, and he's learned through the years that if he comes in and puts his cold, wet nose against my bare leg, it's the most effective thing to do in the summertime to get a cookie. But he's still around. He has not put on his winter gear this year. We've decided that he's going to be 16 next month. He's probably not too interested in going out and playing in the snow, but he certainly is around. It's alive. I took him down to the mailbox, which is a half a block walk, and he was sort of happy to be out. He was not happy about going to the mailbox, but he was really happy about coming home, and he dragged me all the way home from the mailbox. So he still knows where home is. He's losing weight. He's down to 7 pounds now. When he was in fighting trim, he was about 8.5 pounds, but we all lose muscle mass as we get older, and unfortunately that's happening with dear old Charlie. All right, now we're into the polling bit. We get these out of the way. We don't have too many today, but we'll get these up, and standard questions we always ask, which is to what's the current level of DB2 on C that you're running? Knowing is it end of next month that DB211 is out of support. So if you don't have plans to get on to DB212, you can either buy the extended support option or you'll be running unsupported. So let's hope we don't have too many people that are still running DB211. You can see the results there.
Yeah.
We don't have too many people still hanging on. Good news. We'll hide that and share the next one, which is just how experienced is the audience today? This is a question we ask from time to time. And I look on this as kind of a fun question. I remember back in the day when I was living at home with my parents, and in the old house we had, my brother was looking into taking a computer programming class at some place, and they were saying you were a senior person if you had 5 years experience in IT.
Wow.
Those are the days, right?
Mm-hmm.
I graduated from university. It was really hard not to find some sort of job. These days, if you can take a computer programming class and you still have to be able to convince somebody to hire you, that's always been getting that first job is always tough. But what we find these days is our audience and the entire industry on the whole, there's all sorts of people out there who have time to attend a webinar that have 10 years experience or more. I could have put a 25 years or more with DB2 in there. And I probably could have got some answers there, but that's all the polls we got today. We went a little light on that. And just a reminder, this is DBI's new product interface, the main menu they're bringing out with scoring on how well systems are doing and the other things of that nature in terms of CPU time, worst performing, best performing. If you are looking at moving to DB2 LUW, or if you're there already, I'd ask you to consider looking at the DBI tool set. Moving along, that brings us to you, Sheryl. So what I'm going to do, I'm going to come up here, find you, make you the presenter. You'll get a message on your screen. And now we're just waiting for you to accept that, and we see your screen. So as always, I'll monitor the question and answer queue. And And if any questions come in, if you don't mind, I'll just interrupt you and ask the question.
All right. Well, thank you very much and welcome, everyone. I'm excited to be here. I have not done a public seminar in over a year, so this is pretty exciting for me. I designed this one to be a follow-up on what I did last year. And last year, I went into great detail on what the IBM DB2 AI product, it's an IBM paid-for product, how it actually worked in all the algorithms and all that kind of stuff. I'm taking it one step further now because I get a lot of questions about, well, if DB2 has its own data scientist built in who is talking to the optimizer and giving it smarts, is there any other tuning I still need to do? And my answer is absolutely. Absolutely. And this is what we'll present to you today. So a little bit of my background. This was my first SQL class, and it was version 1. It was on a whiteboard, and this was basically it. And I was coming from a very different background at that moment. I had just graduated from college in a robotics degree and was working on jets at Northrop Grumman. So it's very technical. And I was an assembler guru. So you gotta see where my mindset was back then. Is I'm punching out all this machine code, and very, very comfortable at doing that.
Hey, Sheryl.
Yeah.
Just to let you know, can you go into? Would it be okay to go into presentation mode because your screen?
Oh, are you showing the slides? Okay.
Maybe you're showing the other monitor.
Yeah, I'm showing the other monitor.
Oh, okay.
How do I do that?
Are you on a Mac? No, you're not. You're on a Can you right click on the presentation icon down in your lower right? Slideshow icon. Thanks for ringing us up, Roy and Jackie and Jan. Screen. See it halfway down there?
Screen.
No, okay, that's not it. But it looks like you're not showing the right screen. Can you go up to display settings, up at the very top? And the next one over.
Oh, that's
all right. Duplicate slideshow. That will be the easiest.
that works.
Yeah, there you go.
Could that be it? Okay.
Yep, I've seen everything big. Everybody should be happy.
Okay. All
Thanks
right.
very much.
Well, now you can't see what's coming too. That's good.
Yeah.
So imagine I'm an assembler guru, and for those of you who are the newbies, you probably don't realize, but back in 1984, we didn't have any internet. There were no cell phones, laptops, earbuds, email, and a host of other stuff. And then I got sat in front of a blackboard and I got shown SQL. Well, I was not happy. I went into this career actually kicking and screaming. But fast forward to what that language is now. And so I kind of grew up with this language. It started out pretty simple. And in 35 years, it exploded. So it's much more powerful, and it is right now the de facto standard for accessing relational data, wherever it may be in the world. So crazy. So now we can ask all kinds of questions. Well, the beauty of relational is we have this thing called an optimizer. It's cost-based. And it's pretty much SQL, you say what you want, and the optimizer decides how you're going to go get that. So think about it as your transportation choices. And it has to look at time of day, construction, traffic. So this is a lot like Waze. to find your quickest path to where your data is. This is, I'll let it execute, the inside of it, a DB2 engine. These are the components. And this is how a query is actually processed. Now, we've had a lot of enhancements over the years. In fact, this started out about 10,000 lines of code. It's past a couple million lines of code right now, as they've added a ton of functionality. I'm going to go through each of the pieces just so you get an idea that when you type in an SQL statement, oh, that's good, you can see my pointer. It actually has to go through a number of processes, and there are good ways to type in your SQL, and there are not so good ways, and there's good ways to design your indexes, and not so good ways, and there's good ways to ask for a particular sequence or not. So the optimizer for static, it is going to look at your metadata, which is everything to know about your environment. And it's in a static based on your last run stats. But we also do have real-time stats. So that metadata is how it actually can do some estimating and costing. And it does this very, very quickly. They knew, the optimizer team knew this couldn't be a 5-minute bind process. It had to be able to really, really quick get down to the lowest cost. And that, and then let's go to the next one. Yeah. For static, they actually said, okay, now that the world's going static, we need a different place to put these access plans. Oh, there's static. Here's the access plans for the static. For dynamic, they don't go in the directory, they go into a dynamic statement cache. And these plans get bind automatically. So dynamic is just as you're entering it on your cell phone, hitting that button, that happens for your SQL. There we go. So execution time. Once you hit that button, wherever that is, that's when the plan, and it'll come from either place, it'll come from the static or dynamic, but depending on what it is. And these are the instructions to the buffer manager on how to actually go get your data. It tells it the join sequence, it gives you the execution sequence, it steps out the query blocks and exactly how it's going to execute, and it guarantees your sequence that you've requested to return. So it's pretty much code that you can't read in this access plan. And when it follows those directions, it then stores the data in this buffer pool. That's where I'm showing some wetness there. And that is in memory. So and in this memory, this is where a lot of your filtering and processing and your scalar functions, any kind of translations you're doing, all that good stuff happens in that buffer pool. And specifically, we've got these things called stage 1 and stage 2 filters. And they have grown up over the years. 1984, it could do an equal, greater than, and a less than, or something like that. And now there's about 47 things that stage 1 can do. They're very sophisticated and very fast. And this is what's loaded in stage 1. So stage 1 is a component, and it's got about 45 things that it understands. If you code it in these particular formats, I'm not going to go through each one, that you're going to get first access to the data. So there are 4 points of filtering, and the first 3, indexable, which is the left hand, index screening, which is the right hand, data screening is all of these conditions on the data pages. Those first 3 points of filtering are all stage 1. Stage 2 is the anything else. So there are, trust me, far more than 45 conditions that you can copy in your SQL statement. So let's take a look at just an example of those points of filtering, just so you have an idea. And we've got a table join here on token number. And so one thing the optimizer has to decide is which table am I going to first? So let's say it's going to the C table first. It likes the C table first because it's got some C filters going on in this. And the index chosen, the only one allowed, the only one created, was a token number dot roll code, which is kind of a shame because we actually have a filter on the sex column and last name, which aren't in this index. So the first point of filter, we have no idea what the token number is, and we can't even probe that because we can't go by roll code. We've got to go token number roll code. So it skips the first point and actually goes to the second point, which is stage 1 index filtering. So it hasn't done any filtering yet. As it's cruising across these leaf pages, it really is just picking up token numbers as it's going on because it can't satisfy a join predicate. It's got to pick them up, and at least those token numbers are sitting there. What it can do as it's going through these leaf pages is filter that roll code. So minimum, we're getting a certain percentage of rows not picked up based on that roll code filter factor. And then all the rest of the filtering happens at stage 4 to the far right. And this is an example of delayed filtering. This is delayed filtering. This is not the correct way to design your indexes. You want to have all the filters you need when you're attacking your main driver table index. You want to have all of them. So put in roll code. Well, you got roll code. Put in last name. Put in sex, and then you'll have a much better chance at least coming in here, grabbing your pages, only the ones that are going to really make it through the join, and then going to the B table and just picking up right the opposite side of the B table data. So that's how those filters work. Another example. We have, our pages are usually 4K, 8K, 16K, 32K. And that's the manner that they're brought in to the buffer pool, not one row at a time. So they're brought in chunks. The smaller your rows, the more rows you fit on a page. With the example that we have of this query, which has a C1 equals C2 greater, C3 less than, C4 equals C5 between, C1 in, ordered by C1, C2, C3. If on the right, these are the optimizer's index choices, let's go through and see how this will execute. So stage 1, if we go through the C1, C2, C3 index, we get a 2 matching index access, one past the last equal to, C1, C2. And this can do some filtering. And we're showing on the far right a little black marker. That's because it only has intelligence of 45 predicates. And so if it's one of those 45 predicates, it's already filtering that. The 4, 5, and 6, they live on the data. They know they live in another index, but we're not doing multiple index access. We're just cruising through C1, C2, C3. Then we have to hand control over to our other half that says, well, what do we have left to filter? And it's got a big marker because it's almost practically unlimited, the amount of intelligence that this stage can actually process. And it just further filters. So it'll take care of the C5, C6, and C4. And since we picked up everything in perfect C1, C2, C3 sequence, you're actually able to take it straight from stage 2's hands right into your calling program. So there would be no sort. Now, if we throw some percentages in here, just to give you an idea, equals 2, there's very restrictive, but open-ended ranges, close-ended ranges, they're not very restrictive. So let's just say that 20%, at most 50% of the table got brought in, and then another, these are highly restrictive, between is a top and a bottom end, and an in is an equal, and an equal is equal, obviously. These are highly more restrictive, so much more of the filtering brought that 50% down to 2%, and we ended up returning 2% of that table. Now let's go through, I can back up. Yeah, we'll back up. Let's go through the 4, 5, 6 table. Now I am filtering, and I'm down to 2% of the table. But I am not in C1, C2, C3 sequence. So stage 2 is going to have to do whatever's left, the C1, C2, C3, kick it off to a Word file. The wider this Word file is, the shorter, the longer your query runs. So this is why there's always a good performance rule. Don't select what you don't really need to see. You want to keep those skinny. And that's when the sequence happens. It comes back to the calling program. So the work files, they end up with your remaining sorted, translated, perfect data, and then they're handed to your calling program, which could be, again, something that instigated through a remote source like a cell phone. So a little bit more about stuff going on in this SQL. So you got an idea of the optimizer, and you got an idea that there's a lot of decisions to make. In fact, something new is this top of the index tree that is not stored in the buffer pool memory, but its own memory that allows you to IO-free cruise through your indexes so that you can just then directly point to row IDs. So that's a new type of access path. And we've always had multiple ways of seeing, of attacking indexes and multiple ways of seeing the data, which we'll go through some of those. What could possibly go wrong? Well, always, what I mean by a bad SQL is it's not optimal. What I mean about a bad access path, it could be you just don't even have the right supporting indexes for your workload. Always, you got to keep your data as perfect as possible. That can slow down a query. And if you can blow up work files if you don't have enough sort work for your giant, that's called 17 table join that you're doing, and you're retrieving every single column from all 17 tables. So that could possibly blow that up. So here's where we go from here. Now that you got that in your mind, okay, there's a lot of lines of code to go through. All right, so now fast forward to DB2ZAI, a new product. It has a product code. We'll review what it can and cannot do. And then we'll dig deep into really what's left. How else do we change the optimizer's mind, and how else do we tune queries? And I'll leave you with this very fancy how to put a query on a diet, which is definitely something the DB2Z AI can't do. So quick, what can it do? Well, the reason the optimizer can get you an access path, look at it split, is it's 35 years old. In fact, Dr. Pat Salinger was the inventor of this particular optimization technique, cost-based, and it has use of real-time information, and it can also feed itself back stats feedback information. So the algorithms have been refined over the years, and it creates a cost model for every query. That's what the optimizer does. It says, okay, for all these query blocks, here's the cost. Roll them all up, and here's plan A, what's your total? Plan B, what's your total? Plan C, okay, looks like plan C is the winner. Lowest cost wins. But how does the optimizer decide what you put for a parameter marker or a host variable? Well, that they had to default, right? So in a way, you can sum up the optimizer this way. Trillions of optimizer cost-based stuff I can't see it because it's blocked, so you can't even read it here. You can read it. And they're good. They are very good for everybody. And you can thank Terry Purcell, who's leading that charge of that optimizer team. But is it absolutely perfect and great? For many, no. Great for a few. So that's what happens when you've got these things. These are default statistics. So if you are using host variables, parameter markers, these are the numbers that go in when you put in a condition of, something is greater than or equal to is 1/1000th, and something that's like or between, since it has a hard stop, is 3/10,000ths. And these haven't changed ever, and they never will. Terry has said, why change them? They're just guesses, and it would just be make different guesses. So we're used to these now. So this is definitely the one major fault of the optimizer, which they decided to get busy on fixing. Oops, I'll let that draw. I'm going to go back previous. Someone took a lot of time drawing this, so I'll let that actually come through. These are the different amount of access paths, and there's variations of all of them. For a good look at these, I'd point you to some IBM documentation, and if anyone's got any old Platinum Technology posters that have all the access path pictures on it, that's another place to look. And they're also identified in the DB2 Answers book, which is still available on Amazon. So we're not going to go through exactly what all these are, but these are all the choices. So it's amazing that it can run through all those. So the answer to helping the optimizer is personalize your own optimizer within your own subsystem. Get it so that it can learn your patterns and collect the data for your unique operation. And that way, it's not guessing. It'll make sense of that host variable that you put in there, because it'll look at a bunch of stuff. And this is basically a data scientist that's built into the actual DB2 engine. So you invoke it, and it decides itself how to learn, how to model, how to do everything. Does model training, deployment, monitoring, and it retrains the models, and it also cleans up after itself. Now, it costs money because it has a product ID, and there's that product ID. So it's something you might want to just Google and see if you're actually running this thing in your site, because it's not free. But this is making your own optimizer smarter. So it was a good thing they did this. So AI, that's built into it. It's got a nickname, DB2Z AI. And let's dig more into what it actually does. So this is augmenting your optimizer. These are the 4 things that this data scientist helps you with. And I'll just keep saying that it's only 4 things. We're going to go through each one of them. Correcting your estimates. So yes, let's get smarter about what your host variable contents are. Let's get smarter for people who left off fetch first n rows or optimize n rows when they have no intention of actually fetching the run end of their result set, and they just accidentally forgot to put that on. Let's get some sort smartness activity better in there so that we can mitigate large memory usage on our sorts. And let's ignore OLTP, but definitely get more aggressive, because over the past few decades, companies were really shy to use parallelism. So this is a much more aggressive look at packages in their history and their use of parallelism. So that's the current release is 1.2.02. And let's take a look at these one at a time. Well, how can this thing, what does it eat? It eats data. Data scientists are very hungry for data. It has catalog statistics and something we don't have access to, deep execution statistics. That's behind the scenes stuff that IBM put in years and years ago for their own developers to be able to test and know how DB2 is doing. And now they're actually using it to feed this virtual data scientist. And then history. It uses some algorithms. There's many out there, but these are the specifics it uses. It uses classification for known patterns, linear regression for date-time sequencing, and models for random behavior. And then what it does is it executes, it puts itself in a scoring mode. And it runs through the executions. I don't know why, but they picked 100 times. I've asked why 100, and I get just because we said 100. So it'll run through there 100 times, just to get an idea. For instance, if I'm going to fill in a host variable, what were those values for 100 times? Well, now I have a pretty good guess of what they probably will be. Then it throws out a list of packages. This is not auto yet. It doesn't automatically virtual scientist override what your optimizer said without your knowledge. You actually have to move it over to that decision on a dashboard. But the future of this is to be self-tuning. And then, like I said, it cleans up after itself because your behaviors and your data can change. So, you know, models has to be refreshed. So very sophisticated, very sophisticated. Here's fill in the unknown values. This is real old from my very first article I ever wrote. I can't remember what year it was, from my browsing table. How do you get yourself back to where you left off in a multiple column index? And this was the logic that you put together. All these equals and greater thans, equals greater than, equals greater than, greater than. This was where okay, I already fetched 22 rows. Now how do I get back where I left off? This is what you used. Today's technology, it generates the same syntax, but it's much simpler. And you can dig into the DB2 12 book to see how they simplified that. But underneath the covers, it's doing the same thing. And what it's doing is, again, going through 100 times and seeing is there any way, I don't want to X this. No, okay, I can't see what that says there. Anyway, it smartly runs through this 100 times and then figures out, oh, this is what you're doing. Now, at static, it'll do this at a rebind time, and that's when you have to go use the dashboard. Dynamic, as soon as this re-prepares, you're getting the new decision. And you can you can include and exclude all kinds of items, and you'll be given a recommended list, and you'll have to decide if you're going to go with the virtual data scientist or not. So what else could it do? Track your last fetched and your SQL code. Why? There could be a pattern. If I look through this 100 times, I may see that I'm actually closing that cursor at 100 rows every single time. So the next execution, it will be optimized for or fetch first for 100 rows. Why? That turns off some very expensive access paths. Because if you don't have a statement like that or limited fetch clause, the optimizer assumes you're fetching that data set, that result set, to the very end. So this is very nice. You can turn this on for anything that is supposed to be OLTP, and you're not sure your developers actually coded the right statement to get it to not do list prefetch, for example. Optimizing a sort tree. So if you've got SQL with distinct, order by, fetch first, and this is for larger than 4K row sorts. So these are for more of your monster sorts. What they're doing is they're using some intelligence to say, well, if I've just reorged, I'm not going to do a swap. So I never actually swap to another tree, because it's a multi-swap event to actually get you to your fully sequenced results. And so it's basically stopping it at a point where you really need no other sort trees, which is really speeding up some of these sorts. And the last one, parallelism. So again, degree equals any, or DS and Z parm. And now you can be a little more courageous, because now you've got your data scientist who says, you know what, I'm not looking at anything under 10 milliseconds. Don't worry, you're not going to get to parallelism because it won't help anything under that amount. But we're going to definitely look at 120 milliseconds over to see if parallelism can help. And it'll test that out. And if it does make sense, you will actually get parallelism. So then you'll get, in your place, you'll get a parallelism plan. So this is the more aggressive way to let a smarter virtual data scientist figure out if you should have parallelism or not, and safely promote it into your production environment. So that's a mouthful. That's a lot of stuff, but it's only 4 things. So what else? What else is out there? Well, here's my SQL Review Checklist. This is, okay, someone brings me on site. They said, okay, now take a look. We've got this application, and you know, all these programs are running so long, we don't know what's wrong, Sheryl. So I take a look at the program logic. And why do you look at that? You got to see if they're doing relational joins. One shop I went to didn't do a single join. They basically did application joins in every one of their programs. So that's why you got to examine program logic. Your program may be the problem, the way it's coded. Now, does the DDS, does it do that? No, it's not looking at your program logic at all. So this is still tuning you need to take care of. Will the VDAs look in your firm clause? Sure will, but will it verify your join conditions? No, if you leave one off, sorry, you're going to get a Cartesian join. So this is why it's a checklist step. This is code that you've got to put your eyeballs on. Another thing it can't do, sorry, is promote your stage 2s and stage 1 not conditions. These are performance rules. If you can ever recode your stage 1s to be a stage 2s to a stage 1, great. If you could ever undo your nots, that's a manual query rewrite, and your scientist is not doing that either. It can't even prune your select list. So it does what you say, not what you want. You've got to prune your own select lists. Verify local filtering. There's still a little bit to do with how you sequence your predicates. Just keep in mind to keep them most restrictive to least restrictive in the sequence that you type them, and you'll be optimizing your query. And then it's asking the optimizer, so what did you do? What are you doing for me lately? And then you have to make a decision to do if necessary. So hopefully I've proven to you now that you're not done. If you're a query tuner and you want to be a query tuner, there's still tons of work out there to be done. Here's some tuning examples. And this came in version 5, where we actually put in the clause concat, and that's an empty string. It has a name. It's called no operation, and a nickname called no op. And what it does is it tells the DB2, you know what? You had a region as a column on an index, and it looks really good to use, but I happen to know this between wedge is huge. It's the majority of the table. So I want you to not use it to probe an index. But it doesn't make it a table scan. It just says it can't be, it can use index screening, but it doesn't have to go to a table scan. And limited fetch. If you absolutely know what you're not going past, do tell the optimizer precisely, and it will basically ignore a lot of expensive access paths, including list prefetch, unclustered hybrid joins, even some merge joins, because those are really good for large tables. So this just gives you an idea, and this is code you type in. So no, the scientist isn't typing this stuff in. Will the optimizer ignore this stuff? Yeah, it doesn't. Well, it takes it into consideration, and it always will. It won't. The optimizer team is not going to take these tuning techniques away from you. So what are all those access paths? Well, we've got a bunch of them. Here are all those names. And of course you have table scan and yeah, so I'm not going to go through each one of them, but this is the reason that you still may have to look at your access plan diagrams. So here's my general rule. The larger the graph and the more rows, the more costly this is. So if you're using a visual type explain tool, it gives you hints about how many rows are processing. This one doesn't, particular screenshot, but some of them do. Then I got a giant tablespace scan and I'm doing an S loop join between these tablespace scans. That looks expensive. And a tablespace scan that goes through once, and then we're looping through this tablespace scan multiple times through an S loop joins. So just really walking it from left to right, you get a feel for, is this expensive and can I make this faster? So that's the tuning question. The other way you can do it is programmatically. You can run full explains, and one of the tables has processor service units. And these are just relative estimates. If it's a static to static, that's apples to apples. If it's a static versus a dynamic, that's apples to rocks on Mars. So you can't compare the processor service units if the two statements are in the same category. But this is really, now that we're on Z15s, oh my gosh, you got to be into the millions of service units to even come close to being expensive, right? So you're in the 100 millions or the double millions. And in 1 second, you're able to do even up to 100,000 rows in a table in 1 second. So our processors are gotten much faster. So when you run explains and maybe you see some alarming numbers like this, this would be an alarming number. This is 2,147,000,000 and change. And I've seen it in my lifetime. And it actually means something. It's too expensive to calculate because this is a small integer, and this is the largest small integer value that you can have. So you can actually trip the optimizer out. I always consider that kind of a victory if I did that. Anywho, here are the techniques. So we're not going to do index design and MQ design. That's a whole nother hour. We're just going to do a few of the optimize no ops. And then I'll also show you distinct table expressions. I accidentally deleted anti-joins, and we'll end with manual query rewrite. So this is hoping that you'll get a little more information on when should I be specifically using these clauses. So these can be used together. And if it's a distributed application, the optimize number is the rows sent across the network. So think of that as more like a block size. And fetch is the total rows required for the entire set. So it could be optimized for 25, fetch first 1,000 rows. That's how you would use this. And it works at the statement level. And the number one thing it does, it helps you turn off something called list prefetch. List prefetch has got a sort in it. It has to sort your row IDs, and then it's got to go fetch all of your qualifying rows, and then it has got to go get your data. And a lot of times, the larger the sales table gets, the more expensive it gets. It might start sneaking through some of, it may end up in production at 0.81. 0.81 is kind of expensive, really. All your OLTP queries should be at a 0.1 or 0.0 something. So this is definitely not the optimal access path. It's too expensive. If we put in, and why do I always say 22? Because it's my lucky number. Fetch first, 22 rows only. We turn off, oops, that's not good. We turn off list prefetch. It chooses now matching index access, and it can basically cruise through that index and pick up only the 22. and be done and not pick up the rest, and notice the sort's killed too. No operation, here's all of them. +0, concat empty string. -0, but why be negative, right? Multiply by 1, divide by 1. These you put at the predicate level. And what it can is it discourages expensive stuff. However, it preserves index screening, stage 1 index screening. That's that third point of filter I talked about. And you can use as many as you need, and you can fine tune access paths and use this to request a table scan. Those of you on a Linux, Unix, Windows platform, doesn't work there. It basically will laugh at you. That optimizer will just laugh at you. So don't bother it on those platforms. So concat empty string, I showed it one time, and let's look at it another time. If this is my index situation, I've got multiple column index, sales, manager, region. I got another single column index, which I'm not a fan of, manager index, and a region single column index. The optimizer is choosing, it's liking because it sees the sales greater than open-ended range, manager equal, region between. It says, wow, I can do these filters on all three of these index structures and be able to, you know, zoom in into your exact answer and get you your result sets. But if you happen to know you're using host variables and you happen to know, again, that that range is huge, you can turn this off, right? It will basically ignore that region index. It'll pretend it's not even there. Where will it process this? It will still process it on this multi-column index. So it's not that you're turning the filter off, you're turning the option of that index off. That's it. So it's a lot nicer than you know, Sledgehammer, which I'll talk about in a minute. And if you really, really want a table scan, you cannot say optimize for 1 million rows. Trust me, that doesn't work. But you can discourage, 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 and then you'll end up with a table scan. This isn't needed very much anymore, but when you need it, sometimes you just need it, and you just need to put the discouraging in there. And I highly recommend with UR if it's a read-only table, and if you actually have a for fetch only encourages, if you know you're going after a lot of rows, parallelism. And yeah. Should this be documented? Well, yeah, newbies might think this is hacker language. And they might just take it out, because what does a +0 do to a 44? Nothing. So yeah, a little comments around when you start using this. So another technique is what I call a distinct table expression. And this is basically coding a query inside a from clause, where you specifically say select distinct column or columns, and then put an end parenthesis, and then give it a name. So why would you do that? Well, let's go through what can possibly happen. And the reason I discovered this is back in the old days, we had some plans turn from a nested loop join to a merge scan join. Sorry, a merge scan join to a nested loop join, and it wasn't not the optimal access path for this massive join that was going on. So they called me up and said, Sheryl, what do we do? I go, well, you need to encourage proper access. So one of two things happens. If that column that you've identified to be distinct, if it has a unique index, it can directly pull those unique values in. If it doesn't have the unique index, it can gather the data to create the unique index, put in a work file, sort it, and then you get, and that's called materialize. Either way, you get to this logical step, right? Where this was logical, this one actually physically has to get created. And what merge scan loves, sorted result sets, so it's sorted presets. So an example we had, is we had this big table. It kept going first in the join sequence. And that was really clogging up this batch run. And oh, sorry, it was going last. Sorry, it was table X, table Y, table Z. I gotta get my story straight. Which means in a nested loop join, you're looping through table X, looping through table Y, and for however many multiplies, that's 6 rows here and 10, that's 60 times I'm looping through the giant Z table. So not optimal. So what this is, and you probably see some pliers over here, this is very forceful, very forceful. And I purposely put this after I listed table X and table Y to show you that it doesn't matter where you put it in your phone calls, as long as you wrap it in parentheses and give it a name, it will go to that big table first. Sure, yeah, it will go to that big table first. So it's a very popular technique. And another thing that also works and is very similar is instead of the keyword distinct in here, you can use a group by. That'll also force this to happen first. And there's just a lot more restrictions in the group by. So I'm always using distinct. And then another way to use it is the opposite of that. Instead of I want big table first, this company had a problem where it had 50 million row address name table. It was going first. And get this, the result set was only 1,000 rows. I'm wondering, why is this taking so long? They were a bank, they still are a bank, and they designed their tables so they had a bank code. And their hopes were they would buy other banks. Well, unfortunately, they never bought another bank, they got bought instead. And so this has a cardinality of 1. So interesting, when the optimizer is looking at joining your tables, it's looking at your join conditions. And I purposely didn't show them, and I'm just going to tell you about them. So I could fit all this on one slide. That there was some conditions, for instance, between table 4 and table 5, where it says where a column over here is not equal to a column over there. Well, that's not very well known in the catalog tables. So it's not able to guesstimate very, very quickly an optimal table join sequence. And it was giving a table scan on oh, sorry, it was using the index, that 1 column index on this, which is not appropriate either. So this technique was then flipped. Here we're putting the address and name on the outside, and then we're using distinct. Here are the other tables. And why? Because these joins of these tables got it down to about 1,000 people, 1,000 names and addresses. And this is a very old technique, or 0 equals 1. It's like a sledgehammer. It basically says, do not touch that index and please scan this table. So that's sledgehammer in use. So I'll get this distinct table expression. You can drive it to do your big tables first, and you can keep your big tables at bay. So very powerful, very interesting. Yeah, keeps large joined last. And my last one I'll give you is put the query on a diet. This was a data warehouse query. It was in the 16 million in terms of timer-ons, processor service units, whatever. And basically it just wouldn't finish. It's multi-query blocks, one with the distinct, one with the group by, and all kinds of joins. Whew. And here's just the gist of it. The initial join involved all columns and almost all rows. It hardly had any filtering. And this very wide, very deep set was dragged through many query steps. So here's my picture of this actual query. So very wide, lots of rows and columns. And this gets dragged up the food chain. Left joined with this, distinct rows in there, left join with that, another little table, and then inner join, and then finally I get my result out, but I have dragged this thing all the way up to the top where it finally then gets filtered. So here's the diet portion. Why don't we, oh yeah, I forgot to show you, yeah, there was a group by there. why don't we push this group by, because it's going to happen anyway to this whole thing. Why don't we push this group by into its own little table expression and just group by what we need to group by and forget the rest of these columns for right now. We can always go back and get those. So that's the diet portion. And that's why it's also called group by pushdown. Now, does the optimizer do this for you? Very rarely, very, very rarely. It's getting smarter. They're working on it. They're working on that this process happens magically. The data scientist doesn't do this. This is something that's called a manual query rewrite that you're going to have to do. And then you just put the stuff back, because we got to still join that stuff anyway. And then at the very end, when I got all these filtered and joined, I just go back and get the rest of the columns. So this can be used on any platform, a little more details on it. I refer to it as extreme cross-query block optimization, right? Because, and that's where the optimizer is not yet. It does cross-query block optimization, but not 5, 7, 10 levels deep yet. You identify, pre-qualify the core set. Once all the steps are complete, go back and get the columns. And so they call it, IBM calls it group by pushdown. I call it put your query on a diet, which keeps it thin through the engine, right? Keeps it thin. And that query wasn't finishing, now finishes in 4 minutes. So that was a big query manual rewrite that is still an option for you to do. And here's where I give it back to you, Martin. And my hopes was this was a good, useful hour of your time, and that I greatly increased your SQL tuning confidence level. Back to you, Martin.
Thanks, Sheryl. Let me just take control back here. Gotta find how to do that. Oh my goodness, you give me a break, you gotta retrain me.
Yeah.
I've never had that problem before. Not today yet. All right. Yeah, and great information as always, Sheryl. Good to see. Oh, we've got one question here from Jim. He asks, is this similar to a common table expression? I don't know if the way the question.
Oh, yes. Yes, it's definitely. A common table expression can also be used, and that's a with clause above the select statement. If you put a distinct in the common table expression, the same technique works. I am an old school, so I prefer to see them in my from clauses.
Right. Yeah, everybody's got their own way of coding. And
Yep. But yeah, I should probably flip one to, for the new kid.
For the first time in a little while, I'm back tuning a big Z system and looking at buffer pools, and we're sharing screens back and forth, and people are saying, "Look at the way you do your ISPF, and edit and stuff like that." And I said, "Well, I'll learn something from you too." But there's always different ways of coding and doing things. Okay, let me ask this last question here, which is, did you learn anything today? We'll launch that quiz and let people answer that. Collecting answers there, and people are voted. I'd say enough people have voted, so we'll turn that off and share the results.
Woo! Wow!
Yeah,
Wow!
We had
a lot of 80%. 10 years and above. That's
well, there's always something like that. So
very much.
Yeah, when we see that pop up, we know we're doing the right thing, and we will make sure we have you back. And so with all of that, let me close off the questions, close off the show. It
was my pleasure, and giving this presentation, it'll always change a little bit. I've learned just from the question you got asked. Giving it next week at the Chicago User Group meeting. So if people missed it, want to hear it live. I'm also giving it at IDUG North America, Australia. Yeah.
And we'll also have the replay available shortly, and people can download that and look at it all. I've got Sheryl's slide deck already. I'll be making that available. Wherever you are, please stay warm. I think the weather's warming back up. Have a great weekend, and we'll see you in 2 weeks for the next DB2 LUW show on containerization. Thanks again, Sheryl. Be well, be safe, and we'll see you soon.
Goodbye, everyone.
Bye-bye.